Welcome back to AI.Code.Cast. Today, we're taking a deep dive into a pretty cool coding puzzle.
Oh, yeah.
Yeah, it's all about cracking the code, literally.
Oh, okay. I'm intrigued.
So imagine you're given, like, a string of digits,
Okay.
something like 123.
All right.
And your mission, should you choose to accept it, is to figure out how many ways you can decode it into letters.
Okay.
But here's the catch.
Yeah.
A maps to 1, B to 2, and so on.
So like a classic code mapping.
Exactly.
Okay. Sounds simple enough, right?
Well, not so fast.
Oh.
There's a twist that makes it a bit more challenging.
I'm all ears.
It's not as straightforward as you might think.
How so?
You see, a single digit, it can either stand alone
Okay.
or it can be combined with the digit next to it.
Interesting.
And this is where things get interesting because it can lead to multiple interpretations.
Ah, so there's ambiguity built in.
Exactly. It's like you're deciphering a cryptic message where the same symbols can have different meanings.
Yeah. I
Yeah.
see where you're going with this.
Depending on their context, of course.
Right.
So the question becomes, how do we even begin to untangle this web of possibilities?
That's a good question. Where do we even start?
Well, one way to tackle it could be to just try every single combination.
You mean like brute force?
Exactly, brute forcing it.
Okay, so let's say, for example, we have that string 123.
Right.
We could try ABC, then AEW, LC, and so on.
Yeah, but isn't there a problem with this approach?
Well, I can see where you're going with that.
What happens is the string gets longer and longer.
Yeah, you're absolutely right.
It could quickly become a computational nightmare, wouldn't it?
It definitely could. The brute force method, it just becomes unsustainable pretty quickly.
Yeah, my computer would be begging for mercy.
Yeah, exactly. That's why we need a smarter approach.
Okay,
A more strategic way to solve this.
So instead of just, trying every combination blindly, is there a way, do you think, to break the problem down into smaller, more manageable steps?
I think there is, actually. Yeah. What if we, instead of trying everything, we could try to build our solutions step by step?
Interesting. I like where you're going with this.
Yeah.
It's like solving a jigsaw puzzle.
Yeah.
You start with focusing on individual pieces first,
Exactly.
but how do we make sure that we're not repeating calculations unnecessarily?
Right. We don't want to be doing extra work.
Right?
That's where this powerful technique called dynamic programming comes in.
Dynamic programming.
Yeah. Have you heard of it?
I've heard the name, but I'm not sure I fully grasp it.
So it's all about building a solution, like we discussed, from the ground up.
Okay.
But the key is it remembers the results of each step, so we don't have to redo the work.
Ah, so we're not just blindly wandering through the maze of possibilities.
Exactly.
We're leaving a trail of breadcrumbs to mark our progress.
Precisely. It's like we're building this like a roadmap as we go.
I like that analogy.
Yeah. And so let's go back to our example of 123.
Okay.
If we already know, let's say, the number of ways to decode 12, can we use that information to help us decode the entire 1, 2, 3?
That's a really good question. So we're saying the decoding of 123 could potentially rely on the decoding of 12.
Exactly.
It's almost like building blocks.
Yes, exactly. And to keep track of all of this, all these results, we can use what's called a DP array.
The DP array, what is that?
It's essentially like a cheat sheet.
Okay.
Each element in this array represents the number of ways to decode a particular substring.
Interesting. So we're breaking the problem down,
Right.
storing the results to avoid redundancy, and building up our solution step by step.
You got it.
And this DP array is our trusty sidekick along the way.
Yes, exactly. It helps us stay organized and efficient.
I'm starting to see the beauty of this approach.
Yeah.
But what about those tricky edge cases? The ones that always seem to throw a wrench in the works. What if we have a 0 in our string?
That's a great question, and it's an important one to consider.
Yeah, because 0 by itself doesn't map to any letter, right?
Precisely. So how would we handle, for example, the string 06?
06 can't be decoded, right?
And why not?
Because 0 by itself isn't a valid code.
Exactly. So we have to be very careful about how we handle these kind of edge cases.
It seems like we need to pay close attention to the details to avoid falling into these traps.
Absolutely. These edge cases really highlight how important it is to design our algorithm to handle them correctly.
Makes sense. We don't want our decoder to crash and burn.
Definitely not.
So we need to make sure it can gracefully handle these special situations.
Exactly.
And that our logic is robust enough to account for them.
You got it. So we've talked about how dynamic programming can be helpful, but how do we actually use it to, create a solution to this problem?
Yeah, that's a good question. I'm kind of lost on how we'd actually write the code.
Well, we keep mentioning this DP array.
Right, our cheat sheet.
Exactly. So that seems like a good place to start, right?
So we'd create this array first.
Yeah, exactly. We need to initialize this DP array, give it enough space so we can store all our results.
Okay, so if our input, like before, is 123,
Right.
how big should our DP array be?
Well, each element represents a substring, and we have 3 digits.
So we need 3 slots.
You're very close. We actually need one more slot than the number of digits.
Oh, interesting. Why is that?
So we can handle the base case, the empty substring at the very beginning.
I see. So it's like the foundation.
Exactly. So for 123, our DP array would need 4 slots.
So let me see if I get this right. DP0 would be the empty string.
Yeah.
DP1 would be 1, and so on.
Perfect. Now, what do you think we should put in these slots at the beginning?
Well, we need a starting point.
Right.
DP0 is the empty string, and there's only one way to decode nothing, right?
And that is?
Do nothing.
Exactly. So what should DP0 be?
1.
You got it.
Okay, that makes sense. So how about DP1? That's the first digit.
Okay, so remember our first rule.
Can't start with a 0.
Right. So if the first digit is 0, DP1 should be what?
0.
Because there's no valid decoding. But what if it's not 0?
But there's only one way to decode it, so DP1 would be 1.
Exactly. You're getting it.
Sweet. Okay, so now we have DP0 and DP1 figured out.
Right, our base cases.
So now what?
Now we got to loop through the rest of the string, starting from the second digit.
Okay.
For each digit, we need to figure out 2 things. First, can we decode this digit by itself?
Well, if it's not a 0, then yeah.
Yes.
We can just add it to our existing decodings.
Right. And how would we do that using our DP array?
Well, we take the previous count, so DP1, and add it to our current count, which is DPI.
Perfect.
And that's only if it's not a 0.
Right, because 0 by itself can't be decoded.
Okay, got it. What's the second thing we need to consider?
We need to see if the current digit combined with the one before it is valid.
Oh, so we need to check if they make a number between 10 and 26.
Exactly. If they do, then we can add the count from 2 positions back.
Which would be DPI2.
Yes. We add that to DPI as well.
So we're basically checking both scenarios, decoding it as a single letter or as a pair with the digit before it.
Precisely. And we keep doing this for every single digit.
Okay.
And by the end, DPN, which is the last element of our DP array, will have our answer.
Whoa. So we just go through the entire string, and at the end, boom, there's our answer.
Yeah, it's like magic.
It's pretty amazing.
Right. Much better than brute forcing it.
Definitely. It seems like a much more elegant and efficient way to do it.
It is. And speaking of efficiency, remember how we said storing the entire DP array could use a lot of space?
Yeah, like if our string was super long.
Exactly. Well, there's this neat little trick we can use to optimize that.
Oh, you mean where we only need the last 2 results to calculate the next one?
You got it. We don't actually need the whole array.
Interesting. So we could just keep track of 2 variables instead.
Precisely. That way, we're only storing the information we absolutely need.
Wow, so we're saving both time and space now.
Exactly. That's the beauty of dynamic programming.
I'm loving this. We started off feeling kind of intimidated by this whole problem.
I know. It can seem daunting at first.
And now we're finding all these clever ways to solve it.
It's all about breaking the problem down and building upon what we already know.
This has been a really insightful deep dive so far.
It has.
But before we declare ourselves dynamic programming masters, are there any other things we should watch out for?
You're thinking like a true coder. Always got to be on the lookout for those edge cases.
Exactly. Any other potential pitfalls or weird variations that could trip us up?
Yeah, for sure. There are always going to be little curveballs when you're dealing with algorithms, right?
Right, that's what keeps it interesting.
Exactly. So one variation you might see is, what if there are like constraints on the decoded message?
Constraints like what?
Well, what if you can only use certain letters? Or the decoded message has to follow a specific pattern or something?
So it's not just about finding any valid decoding anymore.
Exactly. It has to fit certain rules, like a puzzle with extra pieces.
That definitely adds another layer of complexity.
It does.
So we'd need to adjust our dynamic programming approach, right?
Yeah, you'd have to tweak things a bit.
Maybe add some checks along the way to make sure we're staying within the rules.
Exactly. Or maybe even change how we keep track of the valid possibilities.
So it's like adding filters to our decoder.
Exactly.
We're being more selective about the solutions we're looking for.
Exactly. So it's not just about the number of decodings anymore.
Right. It's about finding the right ones that fit the specific criteria.
You got it. You're thinking about it the right way.
Cool. So it seems like dynamic programming is flexible enough to handle these variations.
Yeah, it is. But you got to be adaptable too, right?
For sure. It's a
Yeah.
tool, and like any tool, you need to know how to use it properly for the job.
Right. It's not one size fits all.
I was also thinking about that DP array.
Uh-huh.
We were storing the number of ways to decode each substring.
Right, like a cat.
But with these extra rules, would we need to store more information?
That's a great point. You might need to store more than just the count.
Like what?
Maybe details about the actual decodings.
So we can check if they follow the rules.
Exactly. You need to make sure they fit those constraints, right?
It's like our cheat sheet needs more annotations now.
I like that analogy. More detailed notes to keep track of everything.
Exactly. We need to be more careful and keep track of not just how many paths we've found, but also what those paths look like.
You're getting it. Now imagine this. What if the encoding scheme itself wasn't fixed?
Wait, you mean the mapping from digits to letters could change?
Yeah, what if it changed based on the context or maybe even as you were decoding?
Whoa, that sounds super tricky.
It would be.
Mhm.
Like trying to solve a puzzle where the pieces are constantly moving.
Dynamic programming might not be enough for that.
Yeah, you might need more advanced techniques, maybe even machine learning or cryptography to tackle something like that.
Wow, so we're moving beyond our comfort zone now.
It's exciting though, right? There's always more to learn.
Definitely. This has been a really awesome deep dive into the world of decoding.
I agree. We went from understanding the problem to finding solutions and then even exploring all these cool variations.
We talked about dynamic programming, saw how to optimize it, and even got a glimpse of some more advanced stuff.
It's been a fun journey.
Absolutely. Thanks to everyone for listening to AI.Code.Cast. We hope you enjoyed this deep dive into the fascinating world of decoding secrets with dynamic programming. Until next time, happy coding.